Let's look at another very common interview question, department highest salary. So we have been given two tables. One is an employee table that has an employee ID, their name, their salary, and what department they belong to. And another is a department table that is basically a lookup table. So what department is what, right? Department one is IT and department two is sales. Let's take a look at the question. Write a solution to find employees who have the highest salary in each of the departments. Return the result table in any order. So basically we need the top earner from each department. For example, department ID 2, we have Henry as the top earner, so we need that ID. From department ID 1, we have 290,000 that are the top earners, employee ID 2 and 5, Jim and Max as an output. And if you see the output, expected output, it is department, they belong to in their name and their salary. This is very common interview question, as I mentioned, and we can see the list of companies it was asked in. So let's write the solution. So we'll break the problem in basically 3 steps. First is we'll assign the rank to each department and employee based on their salary. Second is we'll join the department table to get the name of the department. And third is finally to filter the table with the top earners. Right? Let's write the solution. So first, we'll add the dense rank function. We'll add a window function and I'll explain what to do. Partition by is a group by. So we need to group it by the department ID because that is how we want to know like which department's employee has the highest salary. We will order it by the salary descending. So it will create a rank. So I will alias it as RNK from the table name is employee. Let's first quickly look at what the dense rank will do. So we'll basically add a new column called rank, RNK as we saw. RNK will assign the rank for each of these employees based on their salaries. For department IT, we will have rank 1 for this employee and rank 2 for these employees, right? Because they are tied, they both have 90,000 salary. And for sales, it will also assign rank 1 for this employee 200,000. This should be rank 2. We need these 2 rows as an output. If I don't use dense rank and I use rank instead, there's a function called rank also that will do the same thing, but they will skip adding the rank on both of the tie situations. Rank will do 1 here and then 2 here and then it will add 3 here. It won't match up to the tied ranks and it will skip that rank. So that's why we will use dense here. So let's go back to the solution. I'll quickly run this to see the output. Okay, in the output, we have already created this rank function and we can see the rank is ordered based on the salary. For 90,000 in department 91, we have rank 1 for both of those highest earners as they are tied and rank 1 for this employee for department 92. Right? Now let's make up the output. I'll quickly wrap this into a subquery to join it back, and I will name this query something like I'm not good at naming, so I'll quickly do an X on this. So I will do a select on I need the name from the department, as though I will alias it as d.name as department. That's the table. From this subquery, we need the employee name as employee and their salary. I'm already selecting these 2 from the subquery that I've created. I'll just basically do an inner join to inner join on department, set it as d on d.id equals to x.department id, and that's how we're gonna do a join, because we're gonna join the department id with the ID from the employee table. The final is where we filter it with the rank 1. So x.rnk equals to rank 1. We will only need the top earner. So this will create our output as expected, and our output matches with the expected output. Although the order is not the same because we are ordering by the salary, but it doesn't matter. You can return it as you like. And now we'll submit the solution. We beat almost 80% of the MySQL users. So this is how the dense rank and window function can help you solve problems pretty quickly. Cheers.